Let me share my screen. Let me just see if that is being seen. Okay, so for today, we will be talking about, we will continue talking about sampling, as well as we will go to a new topic called methods of reserve and resource estimation. Okay, so tuloy lang natin yung sampling. So far, how many sampling methods did we learn? We actually learned about 2. One of which is the least accurate, and the other one is fairly accurate, but both of them are very much used in mining operations, and that is grab sampling, and the second one is drilling, for which we discussed so many types. Okay, now we go to the other common types, kasi itong i-discuss natin, hindi siya exhaustive. It's not the complete list, but we will try to look at the more common ones. Okay, so we have what we call pit sampling or pitting. From the word itself, you have a pit. Okay, so this is commonly done during the initial geochemical exploration phases, wherein you dig pits basically na ganito yung kanyang dimensions, pwedeng 1 by 1 square meter. Then the heights would actually vary. It can be like a cube, and then you get the samples from that area, and then you do that. You dig pits, okay, every so often, and then you can also do what some others do. When they get into the pit, they get samples from the 4 walls. They get samples from the 4 walls, and then those are the samples that they get. Okay. I think that's simple enough. We also have trenching or trench sampling. Okay, kung yung pits ay more of uniform yung dimensions, trench or trench sampling would have very long dimensions. Okay, so kaya trench. Okay? They would often cut across the ore body. That's relatively shallow din ito ginagawa. Like in this case, in this photo, you have here the trench, and then you have 2 guys here digging the trench. Okay, this is more common for surface nga, for rock and soil sampling. And then material recovered from each meter of trench is usually stacked separately. And then these are the common dimensions: 10 meters long by 3 to 5 meters deep. And then we also have what we call stack or dump sampling. So stack and dump. So you have stacks or dumps of material, and you are collecting these materials to be stacked at certain intervals or at certain portions. Okay, so you can use an auger, if you would remember the auger drill, handheld, or you can just collect a bucket sample. Okay, in this case, the ones that they got are from the 4 corners. Okay. And then sometimes they also get the center. There's a variation. There are different variations of these methods. Please remember that. Like for this case, 4 na corners. But there are some cases na sometimes they also get the middle one. Okay, madali lang siya. And then next is muck sampling. Muck is a jargon used in the mining industry or in mines, which signifies the material, the unconsolidated material, like here, that is often mined out or excavated. And then if you have heaps or piles of these, ang kukunin sa muck sampling ay yung nandito sa ilalim. Okay? You can use a spade or a shovel or even mechanized ones to get material here. Okay? Yun lang siya. Ganun lang siya kasimple. And then you have alluvial placer or alluvial placer methods. What you do here is you use this to separate the material using their specific gravity, if you would recall those concepts. No? Of course, the heavy materials would actually go to the bottom or sink or will not be carried away by water as easily as the lighter ones, okay? So, ito yung ginagamit sa mga less consolidated like sand, small pebbles, etc. Tapos pwede siyang by scooping or by auger drills yung material, pero gumagamit ka ng tinatawag na ito ay sluice box, itong dalawang to, sluice boxes. If you notice, they are parang beside lang the river. And then pinapadaan dyan. Tapos syempre, yung sa mas malapit dun sa dulo, yun yung mga magagaan. And then yung mga hindi nagmo-move dun sa forward part or dun sa harap na part, yun yung mga higher ang specific gravity. So you're just using the physical property to separate actually. And then you also have channel sampling. So for this case, you use this. This is a moil, or you can use a chisel. Okay, ginagamit to for uniformly distributed mineralization na maliliit usually. If you see in the wall or in the face, the veins, the stringers, and disseminations, itong mga to, ito yung maliliit na mga veins. Kaya siya stringers, ang parang string, ganun yung name niya. And then you cut across the mineral body using channels, okay? So yan, kaya channel sampling, okay? The channels are usually small, like 1 to 2 centimeters by 5 to 10 centimeters. So ganito yung itsura niya. I'll show you a picture. Ayan. So these are two methods of how it can be done. Pwedeng magkatabi, like this one, this is 42 and 43. And then ito naman, yung isang channel niya ito, pero yung isa, ito, nasa baba. Again, this one is a moil. The difference between a moil and a pneumatic chisel, ang chisel ay yung flat yung dulo, yung parang screwdriver yung flat. And then itong moil, ito yung parang patusok yung dulo. Mukha siyang malaking pako of sorts. Ayun. Okay? By the way, again, as I remind you, if you have questions, please do use the chat box. If you're reacting to something, I would also appreciate. I see it open to see how you are reacting to things. Okay? So next is chip sampling. Ito related just sa channel sampling. Kung ang channel sampling ang kinukuha ay yung mga maninipis na mahaba, ang chip sampling is chips. Okay? Maliliit. Na uniform ang size. So in this case, same-sized fragments, 1 by 1 to 2 by 2. Kung yung kanina ay for uniformly distributed, ito naman irregularly distributed or disseminated mineralizations ang chip sampling. It's very tedious and lower cost compared sa channel. Okay? Kasi imagine, ang dami mong kukuning chips from the whole rock or from the whole face. It's relatively fast and quick. Okay? And then, ito siya. So if you have, itong mga plus, yan yung mga chips na kukunan mong, na regular yung interval niya, no? So, kuha dyan, kuha dyan, kuha dyan. So, i-chip off mo siya using chisel or a hammer and chisel or a moil, ganon. Okay? And then next, you have what you call car sampling. Kaya siya car sampling kasi may mine cars ka. So, this is not as used regularly as the other methods. There are mines already that are not using mine cars, but there are still those that do. So, kapag merong mine cars, they only get from certain intervals. Kaya siya car sampling. Kasi syempre, di ba, if you have multiple cars, tapos sunod-sunod, tapos idadump yung material doon. So, for every interval, saka ka kukuha ng sample. Kasi in that sense, parang nakukuha mo yung I'm looking for the word. Representative. Yeah, you're getting representatives, regular intervals from regular intervals. Napubulol ako. Okay, and then, of course, you have bulk sampling. When you say bulk, bulto, tama ba yung word in Filipino? So, large volumes, like tons by bulk. 100 to 1,000 tons. Metric tons ito ha. Tapos, so ito yung magastos ito from kung iisipin niyo, no? Pero saan ba ginagamit yung bulk sampling? Ginagamit ito sa pagde-design at paggagawa ng pilot plant in metallurgical processing, for example. When you're already testing, okay? So, when you're developing the mineral processing flow sheet or when you're maximizing the recovery, you're getting bulk samples now, okay? At maraming pwede pagkunan yung bulk samples, pwedeng sa trial pit, pwedeng trial crosscuts. You will learn these terminologies, no? Madami tayong mga jargon na sa mining ginagamit, like crosscut. What is a crosscut? It's an opening, underground opening, but yun muna yung sasabihin ko. Ma'am Cheska will discuss those. Ano nga ba yung mga openings? Anong pinakaiba ng tunnel sa adit? Kasi, of course, if you don't know about mining, lahat tunnel. Pero hindi lahat. Okay? You have an adit, you have all of these different terms. Okay? So, something to look forward to. Okay. Balik tayo sa sampling. So, after getting all of the samples, so yun yung mga sampling methods, no, na common. After getting the samples, you now prepare the samples. Ito yung tinatawag na sample prep or sample preparation. Okay. So, how do you prepare your samples? So, definitely, kung bato siya, malalaking bato, dapat pupulbusin mo siya or dudurugin mo siya. You put it in a crusher and then you, as much as possible, you will try to make it as small as possible kasi doon na-unlock yung mga minerals. Kasi yung minerals ay nakakabit sa bato, literally. So, you have to liberate. That's what you call the term in metallurgy, no? You have to liberate the minerals from the rock. And then you do that by crushing, crushing and then grinding it. And then saka mo siya i-analyze, okay, for many different properties like density, magnetic susceptibility, electrical properties, And then for laboratory tests, there's a lot of things that you can do. You can decompose the sample through all of these reagents, pwedeng acid, pwedeng different types of acid, HCl, hydrofluoric acid, dilute acids. You can also do oxidation, reduction. And then afterwards, you will now analyze how much material there is. There's a lot of tests that can be done, and these are highly chemical in nature. So, and these are just some. You can see colorimetry, chromatography, visible fluorescence. You have spectrometry, the different types of spectrometry. You have XRD, X-ray diffraction. You have XRF as well, X-ray fluorescence. Wag niyo muna masyadong intindihin yung mga terms, no? Parang masyado siyang technical. But later on, you will know how do these methods work. Okay. And then, balik lang tayo ulit sa sampling. Bawat sampling method would actually have the best or at least the suitable phase of mining where it can be used. So these are just some of those. So for example, sa surface, you can do pitting, trenching, stack, and placer or placer sampling. For surface and underground, you can do drilling, of course. The different types of drilling, sludge, channel, and chip sampling. For quick estimation of run of mine, ROM means run of mine. Ibig sabihin yung lumalabas sa mine. Okay, pag check mo yung grade nun, you can do grab, mock sampling car, or bulk sampling. Okay? So, iba't iba ang applicable. Ganun din sa type ng ore bodies. Iba-iba ang magandang applicable na sampling method depending on what the ore body's characteristics or shape is. Okay, so in this case, ayan, if you would see, may chip or grab or chip or channel kapag thick to medium, kapag very large number of chip samples, kapag gold or rare metals, bulk sampling, and then banded channel sampling. So you will see here just some. Okay? So do you have questions so far? Kasi kung wala na, we will now proceed to the next topic, which is called reserve and resource. Actually, we can also say resource and reserve estimation techniques. Okay. So what's special about reserve and resource? If you would remember your definition sa PMRC, please do not forget ano nga ba yung different distinction dun sa dalawa. So recall. Learning outcomes, just read this by yourself, okay? Proceed na tayo sa reserve and resource estimation methods. In particular, I would want to emphasize here for the next set of slides, the conventional or the old methods, okay? Meron tayong old methods, meron ding new methods, okay? You will see later on ano kaya ang difference nung mga ito. So unang one of the most common methods of resource and reserve estimation in the past, okay, is called the old style. Kasi old, kasi lumang method na siya. Okay. Mind blown. Ang galing, di ba? Ang galing ng pangalan. My old style. So what they do in the old style is they do sampling, okay, at regular intervals. Like ito, tingnan nyo yung diagram. This is, by the way, top view. Tama ba? No. Sorry, scratch that. It's a side view. Okay, it's a, and what's the other term for that? Anong tawag sa ES1 kapag, sorry, ang tagal ko na nag-ES1, like almost a decade ago. Ano ang tawag sa ganung view? Plan ba? Plan view? Anyways, so the side view, ito. Kasi ang drive is a horizontal opening. Okay? Ang winds and race, these are vertical openings. I hope you can understand, no? Ang race at winds ay parang vertical na butas. So, kung may tao dyan, pwede siya umakyat ng race or winds. Pero mahirap umakyat kasi 90 degrees, no? Unless ikaw si Spider-Man. Okay, so, ito yung drive, yung horizontal na openings. Ayan, so side view siya. Parang kinot natin, tapos tinitingnan side view. So, itong mga dots na yan, those are not just dots for aesthetic. Those are actually the sampling points. So, that means at those points, you do channel and chip sampling at 3 to 6 feet intervals along all of those openings. So, doon mo nalalaman kung ano ba ang, ano kayang idea doon sa grade, sa tonnage nung iyong ore block. So, if you notice, madali actually malaman anong tawag dito, ang grade and tonnage, lalo na yung tonnage, kasi imagine niyo kung siya ay regular na block at siya ay, anong tawag dito, geometrical yung shape, kaya nyong hanapin yung kanyang volume kasi may dimension siya. Kung may dimension siya, kaya nyong hanapin yung volume. Tapos kung kaya nyong makuha yung type ng materials dun sa bato, then if you would recall yung topic natin last time, no, you can actually calculate the specific gravity. Tapos ano nga ulit yung specific gravity pag may volume ka na, you can just multiply the two, or at least, multiply the two, or multiply the inverse of the tonnage factor, okay, whatever you're using, whatever system you're using, to get the tonnage. And then you already get the tonnage, okay? So, ayan, ito yung in-explain ko na yun. Nagets ba yun? So, if you have the area and then the thickness multiplied by the SG, or the reciprocal of the tonnage factor kapag naka-feet yung area and thickness, then you can get the tonnage. Okay? Tapos yung grades, of course, ay ina-average out yung mga samples. Okay, next. This one is called the triangular method kasi alam niyo nakakatawa yung mga methods na to. It's obvious kasi gumagamit ng triangles. Okay, so triangle methods, amazing, right? Mind-blowing. Okay, so for triangle method, you use this for flat type or near surface deposits like bauxite or laterite. These minerals are usually on the ground or on the soil. And ang triangular method, useful siya for flat or tabular or like surficial deposits. So, anong special dito? You form triangles by 3 adjacent holes. Bawat hole dito ay isang drill hole. Tapos nakakulay dito, yung black ay intersected na ore. Ibig sabihin, naalala niyo yung figure ko last time, yung last na figure last time, yung kapag nag-drill ka, tapos natamaan niya yung ore body. So yun. Kapag may natamaan ka, yung black darkened. And then kapag walang natamaan, that's the white na, or the empty dot. Okay? Tapos this is a top view. Okay? Top view na to, obviously. So looking at the top, you have several drill holes. So ganito ang drill holes. I discussed drilling a couple of meetings ago. So ang drilling, hindi lang siya isang drill. So you really have to do dozens or maybe even hundreds of drills to properly represent what is down there. Okay? And if you would remember, I told you the cost of each drill. Imagine ano pa lang to, per meter. Per meter of drill is around 20 to 30,000 per meter yun ha, of diamond drill. So, ilang meters ba ang dinidrill mo? Hundreds of meters for every hole. So, multiply nyo yun. Kung halimbawa, meron kang 100 holes multiplied by, let's say, 100 meters multiplied by 25,000. So, that's how much drilling costs. Okay? So, mahal. Mahal siya talaga, no? Now, ang maganda dito, dahil gumagawa ka ng triangles, anong meron sa triangle? Madaling hanapin ang kanyang area. And kung imagine niyo kung meron kang, sorry, may nag-e-echo yata yung voice ko, no? Let me just, kasi I have another device for the, let me just disconnect the audio from the other one. Ayan. Kailangan ko kasi mag-annotate. Okay, so later on, lalo na pag nag-e-explain. Anyways, where was I? Yeah. So if you have 3 holes, like for this case, I will try to annotate now. This one, and this one. Okay. So if you connect that, you can get the area of that. But how do you get the thickness? So if you look at the side view, okay, paano ba? Ang hirap gumawa, no? Kunwari lang. Ganyan. Kunwari ito yung plane mo. Yan. Pangit ko talaga mag-drawing kahit nag-ES1 ako, no? Ayan. Ayan. So parang meron kang Toblerone. Ayan. As I would call Toblerone. Yeah. Get it? Okay, so can you get the volume of a Toblerone? Basically, yes. Okay, so that's just the area of the triangle multiplied by the thickness. And then if you have the volume, then what do you do to get the tonnage or how much material there is? Then you just multiply that again by SG or tonnage factor. Inverse of tonnage factor. Okay, when I say multiply by tonnage factor, I hope intuitive na sa inyo yun na inverse siya. Okay, yun. Baka lang makalimutan nyo. Kasi laging tonnage factor pa man din yung name niya. So multiplier. Anyway, so yun. Always remember that. And then how do you get the grade? So the grade naman is the average of the 3 corner values of the triangle. So ibig sabihin kapag may grade ka nung triangle na to, may grade ka nung triangle na, not triangle, drill hole na ito, may grade ka nung other drill hole, I'll change the color blue. And then may isa ka pang drill hole na color green, ayan. So if you know the grades of those, then you can get the average. And that would be representative to the average grade of the entire, not deposit, Toblerone pa lang, the entire Toblerone. Tapos we have multiple Toblerones. I call it Toblerones kasi mas madali siya imagine, no? And then, nagugutom ba kayo? Naisip niyo ba yung chocolate? So if you have the volumes and the tonnages of the different Toblerones, then you can get the tonnages, the volumes, and even the average grades of the entire deposit. Okay? So ganun yung method. I hope you get the gist of how it is done. Okay, let me erase. Okay. There are disadvantages to this method. By the way, if you have questions, lagay nyo lang. I will try to answer them. Kung medyo hindi pa gets yung method, okay, pwede natin balikan, no, mamaya sa Q&A. Okay, so disadvantages. One disadvantage is there's a lot of ways on how you can create the triangle. Diba? If you have 4 squares, if you have 4 drill holes, now the question is, how do you do the triangle? Do you do it like this? Or di ba may isa pang way? I'll use a different colored. Kung blue, o di ba pwede din ganito? Ayan. Di ba dalawang ways on how you can do the triangle. So which one do you do? Which one do you do? Tama, which one do you do? So there is an algorithm developed by Mr. Delaunay. Ayan, may pronunciation para hindi ako magkamali, no? Kasi lagi ko nakakalimutan. Delaunay. Parang baloney, no? Anyways, Delaunay. I'm not sure if it's a he or a she. They developed this triangulation method, which is actually still used today in many softwares. Kasi ngayon, we don't do this manually anymore. But you will do it in your quiz and in your exam for you to appreciate. And, di ba, parang parang sa math, di ba may calculators, may programming, pero you still have to know the basics. So parang ganun lang tayo. pinoprogram na tong mga to, minomodel na siya, input mo na lang sa computer and you develop the 3D model. But for our case, we will try the old-fashioned for you to appreciate how it's done in the past. Imagine if you were a mining engineer, geologist in the very past. You have to do things manually. Okay, anyway, so yun. So yun yung problem. Another problem is the closure. Parang sa relationship lang. Paano mag-close? yung ating, ang tawag dyan, boundaries. Kasi imagine, yun din, boundaries, yun din. Parang sa relationship lang, no? Closure at boundaries, yan ang problema. So how do we close? For example, do we include, halimbawa ito, do we include this triangle here? How about this one? Do we include that? Do we include that? Paano kung may drill pala yung isa? So that's a kung may value pala yung drill ng isa. So that's how what I mean by closure, no? Pero punta muna tayo sa Delaunay triangulation. I'll explain it in the next set of slides. So okay. So ayon kay Delaunay, the best way to set a triangle or to draw triangles if you have 4 points, medyo ano to, no, geometry, is to actually create tangent circles to 3 points at a time. Again, create a circle that is tangent to 3 points, okay, at a time. And then check using that, okay, meron siyang parameter. Okay, for example, let's see. I'll try to annotate this one. Sa left triangle muna tayo, no? So this one, I will mark these 3 triangles. And then if you draw a circle tangent to, tama ba yung term ko sa geom? Tangent, no? Coinciding, or anyways, on those 3 points, if you draw a circle that is coinciding with those 3 points, or at least tangent to those 3 points, then you have this circle. Okay? Itong red na circle. Okay, if we draw another triangle, let's color this green on the other side. Okay, so the 3 points on the other triangle ay ito, ito, at ito. Diba? Kasi yung triangle mo, ito, ang nipis pala ng aking marker. So ang kanyang circle naman ay ito, yung tumatama dun sa 3 green points ay ito. Okay. Tapos yung sa red, balikan ko lang yung red, yung triangle ng red ay ito, yung ABD. Okay, di ba? So if you try ABD and triangle BCD, okay, and then create circles, okay, Delaunay says the best way to create triangles is if the triangles or the circles that enclose those 3 triangles would not include any other point or would not include any other vertex. Okay. In this case, the red circle here would not include any other points aside from A, B, and D. So siya lang ang laman niya. And ganun din sa isang triangle na BCD, ang laman lang ng BCD ay yung B, C, and D. Okay? Unlike here, on the right side, ito yung incorrect, kaya siya nakapula. Okay. Notice here, I'll try to, let's use a different color, yellow. Okay. So for ABC, A, B, and C, if you create that triangle ABC, and then you create a circle that encloses, or at least includes, or is tangent to those 3 points, A, B, and C, anong napansin ninyo? May laman na siyang, yung circle, may laman na siyang ibang point, which is, anong point yung nasama dun sa circle na yellow? Yes, nasama si D, which is actually makes it at least inefficient or at least yeah, ayun yung ngayon ko lang nakita yung term, no? Circumscribed. We can use that as well. Okay. So yun, I hope you get the point, no? So again, ulitin ko lang yung process. Kapag gumawa kayo, nag-connect kayo ng 3 points, tapos gumawa kayo ng triangle, tapos nag-circumscribe kayo ng circle doon, or gumawa kayo ng tangent na circle doon sa 3 points ng triangle na yon, dapat wala siyang ibang makakain na points. Okay? Kapag may nakain siyang point, like in this case, in the yellow triangle, or even the other one, no? Kapag ginawa nyo rin yung isa, Sige, i-mark ko rin yung isa, yung A. Bakit walang sumusulat? Ayan, A, C, and D. Kapag ginawa nyo tong circle ng A, C, and D, yung black, yung tinatrace ko na black, ano mapapansin nyo, kinakain niya naman yung point na B. So, dapat wala siya ibang makakain na points. Yun yung ibig niyang sabihin. Okay, that's how you know if it's the correct one. Okay. This algorithm is now used in many mapping and modeling anong tawag dito, algorithms. Okay, kasi kapag nagkaroon ng intersection, parang hindi nagiging maayos at hindi nagiging accurate, nagkakaroon ng error sa ano. So yun, kaya mas preferred or at least mas maganda itong nasa left side, okay, kaysa dito. So I hope you got that. I hope I explained that clearly. So now let's go to the next question. Hindi lahat ng triangle ay madaling hanapan ng area. Ano ba ang area ng triangle? If you would remember in your basic math, di ba 1/2 base times height? Pero paano kung yung triangle mo ay irregular, walang base and height? Okay, how do you get the area? So if you would recall, I'm not sure if you're familiar with Herons formula. So this is Herons formula. If you have an irregular triangle na walang base and height, okay, you can use this. So how do you get the area of the triangle using Herons formula? You name the sides as A, B, and C, okay? And then you have a quantity S, which is equal to the sum of those sides, A plus B plus C, all over 2. Okay, that's the formula. And then that S, okay, will form, or at least will be used in getting the area in this final formula here, which is area is equal to the square root of S multiplied by S minus A, yung mga difference nung S with the sides. S minus A, quantity S minus B, and quantity S minus C. That is Herons formula. It's not too difficult to remember, to understand. Yeah, and to remember. I hope you do, baka pag nagtanong kayo, kailangan po ba i-memorize yan? Yes, in this class. And I don't think it's that difficult, no? It's just you have to know this kasi in your exam, I will ask you to calculate some things. For example, sabihin ko na. So, halimbawa, kung may drill holes ka, kunin mo yung volume, kunin mo yung tonnage, kunin mo yung average grade, given yung average grade ng mga deposits. So yun. That's a sample problem. Pero syempre, ano siya, step by step. Kaya naman siya gawin kasi step by step yung problem. Hindi siya isang bagsakan na, okay, blank, tapos, ano. Yun. Okay, so that's for triangle method. Okay, so for the next methods, dadagdag lang ng side. So, we'll add one more side to a triangle, you have a square or rectangle. Now, the major difference between the triangle method and the square or rectangle method is you have your drill holes in the middle. Like, look at this, in the middle of the squares or the rectangles. Unlike in the triangle method, wherein your drill holes are the vertices, are the yung corners of your triangle. Pero ito, yung kanyang drill holes ay nasa gitna. Bakit? Kung yung sa triangle method, ang kinukuha nating, para makuha may average grade nung Toblerone or nung itong triangle na to, you average lang yung tatlong, you get the average or the mean of the three vertices, of the grades of the three vertices. Pero for this one, it's a bit much simpler, which makes it rather more inaccurate. Bawat square or rectangle na makakakain ng isang drill hole, yung drill hole na yun magre-represent na ng grade dun sa buong square na yun. So that's where the pitfall of this method is. Okay, if you notice, ibig sabihin, paano kung malalaki yung squares mo or malalaki yung rectangles mo? Then, inaccurate na siya. Kasi maaaring nagbabago yung drill hole, not the drill hole. Maaaring nagbabago yung grade sa mga depende sa, how would I phrase this? Again, maaaring magbago yung grade depende sa pagka-sinsin, sa closely, ano tawag dito? Closely spaced drill holes versus dun sa widely spaced drill holes. So, highly dependent ito dun sa spacing ng drill holes. In an ideal world, we would want to drill as close to each other. Kung pwedeng ang every 5 centimeters mag-drill ka or every kalahating metro mag-drill ka. The problem is, of course, the cost. Okay, you have to strike a balance between the cost and accuracy. So there comes a point wherein you have to at least be as an engineer or as a geologist, as an expert, you would have to determine how many meters is the sweet spot to at least represent the entire deposit accurately. Okay? So yun. Yung volume, ganun pa rin. So if you have dimensions of it, you have the area, and then you have the thickness of this. Again, this is top view. Okay, and then the grade is the average grade hole within your rectangle. A similar method, but more abstract yung shape. Ito is yung polygonal method. Ito, ang difference nito dito, ito, in a way, kino-consider niya yung mga irregularities, irregular intervals. Kasi ang hirap na gawa ng square na shape no, kapag irregular na yung spacing ng holes mo. So, this is the polygon method, also known as the polygonal method. Ginagamit din siya sa flat type or near surface deposits or yung mga bauxite laterite deposits. Ganyan. So, may relevance siya sa triangle method, no? Kung yung triangle method, yung mga drill holes ay pinagko-connect mo yung tatlo para maka-form ng triangles. Ito naman, nagdo-draw ka ng perpendicular bisector between every drill hole. Areas are planimetered or calculated. Again, nagdo-draw ka ng lines in between or gumagawa ka ng perpendicular bisector sa pagitan ng bawat drill holes. I'll show the process to you in a while. Pero imagine if you have all of these polygons, okay? Polygons yan, so may areas yan, may sides. So pag may polygon ka, technically kaya mo makuha yung area, okay, nung polygon. You now calculate the volume by multiplying the area and thickness, and then get the tonnage by multiplying that volume to SG. And then the grade naman here, similar with the square or rectangle method, is actually represented by the single drill hole at the middle of each polygon. Okay? What are the disadvantages naman of this method? So in an irregularly sampled area, the zone of influence of a drill will vary inversely with the density of sampling and not according to the mineralization. Okay, parang ang technical ng pagkakasabi, pero ito lang din yung in-explain ko kanina, just a while ago, na nakadepende yung accuracy mo kung gaano ka sinsin or kung gaano ka near each other at kung gaano ka far apart yung iyong drill holes. Siyempre, the farther apart they are, the more inaccurate and imprecise your values are, okay, na makukuha mo. And then another problem similar sa triangle method at sa love life, ganyan. Problem din ng closure, okay? So mas lalong problem siya dito. Imagine, so paano mo nga, pag may mga lines ka dito, so paano mo i-close yung diagram? Wala ka ng drill hole doon. Ito naman may drill hole ka pero walang laman, so i-close mo ba yun? So how do you deal with that? So that's another problem, and it's kind of subjective. The closure and the boundaries. Okay? Yes. Nakaka-relate ba ako? Charot. Nakaka-relate ba kayo? Ayan. So here is what you do in the polygon method. Okay. So I will need my annotation thingy. Okay. So first, what you do to create the polygons is to try to connect each of the drill holes like so. Well, ito yan. And then, afterwards, you get the perpendicular bisector. May ES1 kayo, di ba? So I hope you know or you are familiar with perpendicular bisector. Pero just in case, if you are not, so from the word itself, perpendicular bisector, it bisects or hinahati niya yung gitna ng line ng mga nagawa niyo. So itong line na to, whoops, hindi siya nag-annotate. Bakit? Okay, so halimbawa itong line na to, ang kanyang gitna ay ito. So perpendicular. So gawa ka ng perpendicular line to that line that you just made. Ganon din dito, gitna, tapos perpendicular to this. Ganon din dito, kaya perpendicular bisector. It bisects the line perpendicularly. Okay? Now, those perpendicular bisectors will actually form the polygon. So in this case, if I continue this, if I continue that, they will actually meet. Yes. Ayan. Amazing. So, hindi diretso yung drawing ko, pero halos kamukha niya. Ito. So, yan. And that is now your polygon. So, imagine doing this over and over and over again. So, that is how you do the polygon method. And this is how it looks like. Okay. Ang daming nakasulat. Wait lang. Let me clear. Okay. So, actually, in this diagram, interesting siya. You can see two things. The polygons are actually here. Let me mark with red. Ayan. Yung mga dotted lines, those are the polygons. Pero, if you see the connections of your points themselves, you would actually see the triangle methods. Ito yung triangle methods. Right? Ang magkaiba lang sa kanila yung area of coverage nila. In this case, mas malaki ang area na nako-cover ng iyong triangle method. 'Di ba? Mas expansive siya, hanggang dito yung triangle method eh. Pero yung polygon method ay may problema siya sa closure. Problema siya sa closure. Ito yung boundaries ng iyong polygon method kasi hindi na na-close yung outside borders. Okay? Do you understand? I hope it's not too difficult to understand, ano, or not too complex. Okay. So next, we move on to the next method. So another, actually, may nag-comment, no, mukha daw siyang piatos. Actually, sometimes they call this as the piatos method kasi mukhang piatos yung mga polygons. Thank you for mentioning that. Mukhang piatos yung mga polygons. Okay. We move on to the contour, isopack, or isograde method. Have you seen a contour map? Or at least do you know how a contour map looks like? Or I mean, what it's for? So ang contour, yung regular na contour ha, ito kasi special type of contour. Ang contour map, kapag meron kang, gawa na lang akong bago. Ganyan. Yan, contour. Okay, tas may values to. Halimbawa, this is, for example, 20 meters, ito ay 30 meters, ito ay 40 meters above sea level, for example. So, ibig sabihin, habang lahat ng points na nandito sa iyong line ay magkakapareho ang elevation. Okay? Kaya sa contour map, you will have, nagpapakita siya ng elevation. So, ibig sabihin, itong part pala na to ay parang hill. Itong dinrawing ko, para siyang hill kasi pataas siya ng pataas. Okay? Yung elevation. So, yun ang contour. But in this case, this is a special contour. Well, we adopt the term contour. But instead of heights or elevations, grades ang ating mga contours. So, in this case, this here, the outer border, lahat ng area na yan ay nire-represent ng grade na 1%. So, ibig sabihin, at this points, lahat daw ng grade dyan ay 1% of whatever metal. Ano ba, 1% copper, ganyan. Dito naman ay 2%. Paano ko nasabing 2%? Kasi 3% yung susunod. So what's between 1 and 3? Definitely 2. So ganon. Ganon mag-assume ng ganito. Okay? So yun. Nagets ba? I hope yes. So, let us see what else is gonna be mentioned here. Okay, yeah, relatively in lower elevation siya, no? Ang hirap gumawa ng contour. Imagine yung contour map, for example, ng what we call this, Mount Everest. So that's thousands of elevation. So imagine mo yung contour mo ganun, no? sobrang sinsin, di ba? Ganon. As in, sobrang ano na. So actually, ganun siya no, sa contour map. The more masinsin your lines are, masinsin talaga. What's that in English? Kanina ko pa ginagamit yung masinsin. Sana nagigets ninyo yung meaning. Habang mas masinsin ang line sa contour map, mas higher ang elevations. The wider it is, or the higher the gap, ibig sabihin mas gentle yung slope. Okay? So ganun din dito. But again, in this case, we are talking about grade. So kapag ganito, malalayo, gentle yung difference, or at least hindi madaling mag-change yung grade. So ang disadvantage na tong method na to is paano kapag abrupt yung change ng grade mo from one area to another. That's the disadvantage of this method. By the way, the lines are called isolines. Okay? So constructed by interpolation between points of known values that assume a gradual, uninterrupted change from one point to another. Ito lang din yung sinabi ko, no? So ini-interpolate nila yan, ina-assume, depende dun sa mga drill hole values na nakuha nila. Okay? And then when you say isopack, that is the thickness of the contours. Okay? So ganun lang siya. So this is an example of an actual ang tawag dito, contour or isopack map. So in this case, what we could see here are the grades. So yung isolines daw here are the copper ppm. So ibig sabihin, at this point, 200 ppm. So doon ang high grade. Okay? Ang low grade ay ito, yung mga 100, 50, 25, ayan, may mas maliit pa ba sa 25? Ayun, mukhang ito low grade, ganyan. Low grade. Ang mataas talaga, ito 200, high grade. Yun. High grade, ito. So yun, yung mga areas na pinakita ko. Okay? So that's just how contour lines, or at least in the context of grades, contour grades work. Okay? So, sabi ko nga, the disadvantage is it's limited to deposit showing gradual change. It has a hard time if it's very abrupt yung change ng grades. And it assumes that the values can be contoured. So, yeah, its assumption is that parang meron kang mako-cover na area na same ng grade. Pero in reality, in modern times, hindi siya ganun kasimple, no? Like yung before, yung pinakita ko, paano kung disseminated yung grades mo? Like that. Side view to. Kung wari, ayan. Disseminated. Side view. Ayan, may puno. Grade 1 drawing. Anyways. So kapag, ayan, may mga ganyan ka, ang hirap na gawan ng isopack niyan. Okay? Or isograde or contour method. Okay? So yun. Kaya di ba pang flat and ang tawag dito, uniform deposit siya. Okay, so next method. Okay, medyo madami-dami pa. Ay, hindi naman, konti na lang. The next method is cross-section method. From the word itself, we look at cross-sections. Ayun yung hinahanap kong term, cross-section. So, side view, cross-sections. Okay, so in this case, itong parang may mga posporo na nasa gilid. That's actually the cross-section. Itong mga parang posporo, yan ang drill holes mo. Yes. Ayan. May isang, take note, dalawang cross-section to, no? Isang cross-section dito ng lupa na to, tapos isang cross-section dito. Tapos, ano yung parang bulate na to na nasa ilalim? This is actually the ore body na sumagpas, na na-intersect nung iyong drill holes. So, kapag nag-connect ka ng dalawang ang tawag dyan, cross-section na parallel to each other, you can actually assume that it depends, no? If your ore body is continuous. Nai-imagine nyo na. So you can now see the ore body. Okay? So ganon. So clear. Clear. So that's how this works. Let us zoom out. Let's look at this. It estimates a block of ground that is bounded between regularly spaced sections. Okay, so the drill holes here are regularly spaced, if you notice. The average grade is calculated by weighting the area of this respective sections. Naalala niyo yung weighted average? So ang weight, ganun din dito. Ang weight daw ay yung, excuse me, Excuse me, I just ate, so I'm having a lot of gas. The area. Okay, so anong gusto ko sabihin? Na-distract tuloy ako. Inom nga akong water. Ang hirap kapag ano, no, naka-record talaga yung voice mo. Your burps will be heard. Unlike in class wherein you can like, I mean in face-to-face classes. Okay, where was I? There are halfway demarcations made between drill holes, okay? In this case. Siguro mas ma-appreciate natin pag nakita natin yung isa pang version ng cross-section method. This is another version of the cross-section method. The drill holes here are not as regular as the other one in the other figure. Look at the drill holes here. The drill holes are this one. I'll color with red. This one. By the way, in real life, baka nagtataka kayo, bakit ganun yung drill holes diagonal? Yes, we do drill holes na diagonal para ma-hit yung ore body. Okay? Ganyan. Ito pa nga galing sa isang point tapos dalawang direction siya. So yun. Tapos ang ore body kasi dyan ay ito. 'Di ba? Mas madali nga namang makuha yung shape ng ore body na yan kung ang yung drill holes ay ganyan ang direction na red, kaysa kung imagine niyo kung yung drill holes niyo dyan ay puro ganyan. Ang lalim ay baka mas kailangan mas masinsin, no? Something like that. Okay, so this is also cross-section method, no? Yung sections here na sinasabi ay yung halfway demarcations na nabanggit kanina ay nawala yung red. Okay, ulitin ko lang. Ito yung mga drill holes. Ang halfway demarcations dyan ay kukulayin ko ng green. So halfway between this and this is this one. Yan, yung mga dotted lines. So, ibig sabihin, dito sa first section, ito yung represented nung grade na to. Dito naman sa susunod, I'll change the color. The blue part is represented, the grade could be estimated to be the value of the grade of this drill hole. And ganon, I hope you get the idea. Ito namang section na to, na yellow, ang grade daw dito ay nire-represent nitong drill hole na yan. So ganon. Okay? So let us clear that. And advantages. It portrays graphically the geology of a deposit while the general procedure is simple and rapid. Okay? Relatively simple siya. However, magkakaroon ka ng complex calculations kapag, una, poor yung selection mo ng section lines or kapag nag-interpolate ka. Tapos another is, ito yung medyo complex, no? Paano kapag nag-i-intersect na yung mga drill holes mo? Ang hirap na gumawa ng sections. So yun yung non-parallel na siya, tapos irregular na siya, ang hirap na gumawa ng sections. So that's the problem with this method. Okay? So let's look at another example. Cross-section pa rin to, different diagram. So ang drill holes niya dito ay ito, si DDH1, DDH2, si DDH4, DDH3, tapos meron siyang samples na nakuha, si T2, si T1, saka si C2N. Si C2N may mine na daw kasi sa ilalim, kaya nakakuha siya ng samples sa C2N. Okay? So the sections here respectively are A here, A, you have B, which is represented by the grade of DDH1, C, represented by the grade of DDH2, C1N, nakalimutan ko pala si C1N, ay, D, si D na represented by the grade of C1N, and then you also have A prime, B prime, C prime, and D prime. Iba ang A, B, C, and D sa A prime, C prime, B prime, C prime, D prime. Kasi magkaiba sila ng horizontal distance. Ang gusto ko i-point out doon ay itong nasa taas ay 100 north. Ito ay 200 north. So, ibig sabihin, pagtatabihin nyo sila or pagtatapatin. Parang yung kaninang drawing, ito, yung sa unang-unang natin pinakita sa cross, ayan, parang ganyan, section A and section B. So, ganun yung mangyayari. Na-imagine nyo ba? I hope. So, for these two sections. Okay? Okay. So, now let's proceed. So, nakuha na halimbawa yung mga areas. Okay? Nung A, B, C, and D. Ayan yon. Areas. Ganon din sa A prime, B prime, C prime, and D prime. Paano mo yung area? Madali lang kasi mga parang rectangles lang to. So pwedeng i-assume or even polygons. Okay, so if you now have the areas, what do you do next? You have to have the grade. So ang grades nito ay yung grades ng mga drill holes, yung mga nakuha nila sa drill holes. So na-analyze nila, ayan. Tapos pansinin ninyo, the grade of the entire block, when I say block, yung pag binuo nyo to, pinagtapat nyo, tapos gumawa kayo ng parang box using these two sections. The grade of the entire section, not section, ano tawag sa kanya, block, is actually calculated from, the grade of the entire block is calculated from the grades of each section, tapos naka-weight siya. Diba? Weighted average lang din. So, etong area multiplied by the grade, ito siya. Tapos sum of these products divided by the total area. Okay. Ay, actually, yung pinakita, ito pala, layo ng tingin ko. Itong 5891 divided by 326. Actually, na-typo pa nga, no? 3260 dapat to. Sa luma na kasi yung reference, hindi ko alam. 1.81. Tapos ito naman ay 8563 divided by 4896, 1.75. Hindi ko alam. Uso siguro sa kanila yung ma-typo dito. Lumang reference na kasi itong pinagkunan ko nito. Kasi malamang lumang method na siya. So, this is another, whoops, let me clear the annotations. Ayun. So, kapag nakuha mo na yung, di ba meron ka ng total area nung isang section, tapos average grade nung section na isa, yung 100 north, saka section nung 200 north. So, ito yung kung paano mo makuha yung sa buong block pala. So, add the areas, ganun din, a weighted average pa rin. So, area of the entire section, 100N. Not the entire section, no, the entire big section, yung buong, ano na yun, yung buong rectangle. And then, multiply by the average grade, tapos ganun ulit, the sum of the product of the area and the average grade divided by the total area would be the representative grade of the block. And then, the volume, okay, ito, kinalculate nila yung volume. Kasi kung may distance ka between 100 and 200, which is obviously 100, okay, so i-calculate mo lang yung volume. And then, if you know the tonnage factor, ang tonnage factor niya dito ay obviously 9.5. Diba? Minultiply yung kanya reciprocal. So, kaya nyo na makuha yung tonnage. This is in feet, by the way, kaya tonnage factor yung ginamit. Okay? And I think we will end with that for today's meeting, no? Baka masyado ng overload. We will continue na lang with the next, in the next meeting. Now is the time for the Q&A. So if you do have questions, please put it in the chat and we will now answer your